Hey everyone, thank you for joining my session today. So today we're going to dive into what I think it's an exciting topic, and Jarek already kind of touched on it a little bit. So we'll be speaking about the NgOptimized image directive in Angular. We'll explore the powerful directive, how the directive can significantly enhance your performance and user experience of your Angular applications. Yeah, so before we get started, let me introduce myself a little bit. So my name is Sonu Kapoor. I'm a senior Angular developer consultant. I have worked with various top Forbes 100 companies and helped them with their Angular projects. And like Chris said, I'm also an Angular GDE and a Microsoft MVP. In the past, I did contribute quite a bit to the Angular framework and created over 100 pull requests. And yeah, I'm also co-host of two podcasts, actually. One is the Angular Catch-Up, and one is a generic podcast with Santosh on tech topics. Cool. All right, so coming to today's topic, here's what we're gonna cover. We'll start with a brief introduction on the directive, followed by an overview of the problems with traditional image handling. Then we'll talk about some key features. And I don't have a demo like Jarek had, but the screenshots and everything I showed, I've built an application out of that you can download from this repo here that you see on the screen. Okay, so the directive was introduced in Angular 14, so quite a while ago, and it was fully operable in 15. It's also one of the most underused features I find in many Angular projects, and I've seen many of them. So the main goal of this feature is to improve performance and enhance also the user experience. And I think that aligns really well with Angular's mission, to provide developers with powerful tools that makes development of web applications a lot easier. So you may be wondering, what's the problem with traditional images, right? So traditional image handling in a web application often leads to significant issues like slow load times that can frustrate users and also negatively impact your site's performance. When the image doesn't load, it just looks bad on your website, right? High bandwidth is another concern, especially for users that have limited data plans or are in regions with slower internet speeds, right? So your best image that you're showing on your website might be good for high-speed users, but when you have limited data, it might take a long time to load. So the directive can help definitely with that. And then also, ensuring that images are responsive and look good on all devices can also be quite challenging, right? It requires manual adjustments and multiple image versions and so on. And you may even have to write code to understand on what device you are, and then depending on the screen size, you could load different versions of the image. So that's also one of the concerns, right? So let us see how this directive can help us. So unlike the standard image element, right, the directive can automatically handle image resizing, lazy loading of the images, and it can use placeholders when your image is still being loaded. So that ensures that users, for example, always receive either the most optimized version from the device, or they see a placeholder, or they see something else that is happening while the image is being loaded, right? So this on its own gives you a much better user experience, as the user can see that there's still something happening on the screen. So let's start with lazy loading, right? So the directive can be used to defer the loading of off-screen images until they are needed. And that again reduces your initial load time and also improves the perceived performance of your application. So all you have to do is add the loading attribute and set it to lazy, right? So while this actually sounds awesome, you should only use this for images that are not in the viewport, okay? So if you're using images that are above the fold, then you do not want to use this at all. In that case, you want to eager load the images, as you probably want to show them as soon as possible. And by default, lazy is set to all images that are not marked as priority. So you have to be really careful with that. Jarix was showing a demo about that previously, and you could see it there. Yeah, so as I mentioned, eager loading. When the image is marked with priority, then the fetch priority is automatically set to high, and that causes the image to be loaded eagerly. And that means, we're giving instructions to the browser to download the image as soon as possible. So we're helping the browser to make that decision. And when you set the fetch priority, it will also improve the LCP, which is the largest contentful paint. So LCP is also known as the loading metric, used to identify how long it takes for the page to load. And most of the time, this is done by looking at the largest bit of content that is loaded. In many cases, that is an image element or an H1 element or something like that. And because we're talking about images, right? So images take much longer to load than text. So the browser needs to find the image, it needs to download it, and it needs to display it, right? And to help the browser, we can set the priority. But to understand really what that means, right? Setting the priority. Let's first see how this looks if we don't use the priority at all. So consider the following image element. By default the priority of this image will be low, right? So we're not using any directive here. It's just plain HTML, right? And so when you can see that in the priority column of your network tab here, right, marked with number 2, that the priority is set to low first and then to high, right? So normally you would only see high unless you enable the big request rows option that you see under number 1. So this is really useful because we understand now that, first the browser is doing a lot of additional work, right? So first it sees the image, it marks it at low, and then it knows that the image is part of your viewport, and then it sets it to high, right? So this is where the priority attribute comes into play, right? So if we add the fetch priority now and set it to high, then we're telling the browser that this is an important image and we want you to download it as quickly as possible. Okay, so when you look again at the priority column, you will see that the initial and final value is set to high. Okay, so that means the browser has to do less work to show the image, right? And again, this is really useful for images that are above the fold, right? Your banners, your logos, or anything that you want to appear as soon as possible. Yeah, so under the hood, this is what happens when the when priority is set. And to use this, right, all you have to do is obviously first change the source attribute to ngSource, and then we just add the priority attribute. You can see that here on the left side in the second code snippet here. And another cool thing about this is that if you're using the directive, with an image provider, and you're not setting the priority, but your image is above the fold, then the directive will throw an error saying that the image should be marked with priority. And I think this error message is really useful to make sure you do not forget that. And Jarek had a nice demo on that one as well when he was showing the error in the console, right? Okay, so let's move on to the next feature of placeholders. So placeholders, the placeholder attribute helps you essentially to manage how a placeholder can be used while the image is loading or still being fetched. And this on its own provides a much better user experience. And if you're using a CDN like Cloud Binary, right, that supports multiple images, image resizing, you should automatically receive a low resolution image for the placeholder, right? And you don't need to set any value for that attribute, right? So while the image is still downloading, you will see a low resolution image, and I think that on its own gives a much better user experience. But if you want to use a completely different image, right, then you can also set the placeholder to an encoded version of the image in base64 format. And here's how this could look if you used a base64 spinner. So one thing to keep in mind is that these base64 images should be kept small. Otherwise, you will get an error. And this is the error you would get, right? So the Angular team, takes developer experience very seriously. So when you use an image that is larger than 4 kilobyte, you will get an error message like this. And the team recommends to keep the images smaller than 4 kilobyte. So one thing you will notice is that the base64 image here is quite blurry, right? So it's actually not the image itself, it's the directive that is doing this. I think it gives a nice user impression that the final image is still being loaded. But you can also disable this effect. If you do not want to have this blurriness, you can disable it by using the placeholder config and setting the blur key to false, right? So this is how it would look. And this is how the base64 image itself actually looks, right? So yeah, this completes the priority and placeholder topic. Now in the next section, we'll speak about loaders, which I mentioned earlier, like Cloud Binary, right? Which is a CDN provider. So the benefits of such a provider, is that it will automatically create multiple versions of your image. And with the help of the directive, the browser can then download the right size for your device, right? And to use this, you need to set the loader in your provider's array using the provide. So here I'm using Cloud Binary, right? A Cloud Binary, and you would have to use the appropriate function for that. So Angular gives you 5 pre-configured loaders that you can use. And here's the list that here's a list of providers in case you're wondering, right? But also, if you want to use your own provider, you can do that as well. So for that, all you have to do is provide the image loader DI token and a loader function that takes the image loader config as an argument and then returns the absolute URL of the image, right? So you import both of these from the standard Angular common package. And additionally, there is a loader params parameter, excuse me, that can be used to pass anything from the directive into your loader function. And here's an example how that would look, right? So we just set the loader params input and define the value we want to pass through. So in the loader function, then we use this property to modify the behavior of our loader, right? So in this case, we're adding the rounded corners query parameters to our URL, right? So this way you can essentially pass anything you like and pass it along to the final URL for the image. One more thing to get the loaders to work is that you need to add the pre-connect links to your index.html. So pre-connect, again, gives the browser instructions to download critical resources as soon as possible. And without pre-connect, the browser, again, has to do additional work to discover them. And again, Angular helps you to not forget that, right? So the directive will throw a warning into the console, reminding you to add pre-connect into the head of the document. Cool. All right, moving on into the next section. So we'll be speaking about responsive images and how they can save a lot of time. So the directive will automatically set the source set attribute with the necessary information which tells the browser to download the best possible image, based on your user's device. And this can work with or without the size attribute, right? So if you set up your image without the size attribute, then the directive will automatically generate the density dependent source set. So that means that the 1x image, will be automatically downloaded by the browser on low pixel density screens and 2x for high density screens. And what that means is that a higher density, or also called device pixel ratio, DPR, on screens generally means a higher pixel count, which also means a better image quality, right? So here we can see that the source set is set automatically, right? One for 400 and one for 800, right? So these are the two source sets that the image will contain when you inspect the element. So to give you an example of a DPR, right? Most newer iPhones even have a DPR set to 3. Android, for example, is way ahead, and there is either 3 or even higher, right? So if we look at our previous example, right, we can see that in the left screenshot, the image downloaded is 400 by 400 when the DPR is set to 1. You can see that at the top, right? And when the DPR is set to 2, you automatically get a much better image. You can see that in the right side, which is the 800 by 800 image, right? So you can imagine on the iPhone you would get the left image, and on the Android you would get the right side of the image. So adding the sizes has a similar effect. So here, I'm setting the image to be 80% of the viewport, and it will automatically generate the source set for all available breakpoints. So here is the list of breakpoints, if you're wondering. So this is what it's going to generate for you. And this is how it's going to look inside your element, right? So I think this is, again, right, very helpful, as you don't have to worry about providing all the different sizes yourself for each breakpoint, right? And as you have previously seen, the browser will automatically request the image that fits, your device, and you don't really have to worry about writing any additional code to handle this. And yeah, if you only support a subset of breakpoints, then you can also customize this list by providing the image config DI token to your provider. So this will then generate the source set only for the given breakpoints. And you can also, of course, define your own source set using the ng source set attribute on the element itself. So one of the common use cases is when you want to use media queries to control the image size, right? So one of them is, for example, you want to render multiple columns on the desktop while rendering only a single column on mobile. So here's an example. So the directive will use 100 view width as a factor to download the image on a viewport with maximum 768 pixels. Right, you can see that in under sizes. And otherwise, we want to use, otherwise it will use 50 view width, right? So what that means is that when you have two columns, when two columns are displayed, then the images will be smaller because you have less space. And when it's a single column, you will get a larger image, right? So setting the sizes with media queries can be quite helpful. And you can see here on the screen that if I resize the window, right, the Angular directive automatically replaces the image with a different size, right? And yeah, that's it. I hope this presentation was useful. And again, you can find the examples under my repo here in the footer, or you can connect to my main repo here and find also other examples. And please feel free to connect with me on LinkedIn and Twitter. I'm happy to answer any questions you might have.
Okay, Sonu, thank you for the great presentation. And now let's dive into the Q&A session. But I don't think we've got any questions yet, so that's the last chance to ask them. And in the meantime, let me ask one from my side just to clarify that. So would you consider applying NgOptimized image pretty much to every image in the application, or rather consider it case by case? Sorry, Sonu, could you hear us?
I'm having some trouble hearing you. Okay, I can hear you now. Yeah, I can see you now.
Okay, so
Sorry about that.
yeah, so I was saying that I think we don't have any questions yet, but I might have one just to clarify this in the meantime. So would you consider applying the directive and the optimized image to every image in the application, or maybe rather consider it case by case?
Yeah, I think I would consider it case by case, right? Especially, I would especially apply it to images that are above the fold, right? Because I want those to be loaded as soon as possible. And then I would apply it to those images as well that are not in the viewport actually, and make sure that they are lazy loaded, right? So it's always case by case. Don't take everything as thumb of rule that you should apply them as soon as something is available.
Yeah, that's great. And we have another one from Gulam Asgar. What limitation does NgOptimized image have with external CDNs?
That's a good question. I'm not aware of any limitations with CDNs itself, right? So they work pretty well. Um, the only limitations I know with the directive itself is about the sizes, right? So you always need to provide a size, otherwise the directive does not work. It's actually a requirement to provide the sizes. But CDN itself, I'm not aware of any limitations.
All right. So I guess that would be it for the Q&A session. So again, Sonu, thank you very much for joining us
Can you
today.
hear me?
Thank you
Yep. Okay.
for your valuable contributions. And yeah, I hope to see you soon. And take care.